thank you everyone for joining us and welcome. So Axiom Cloud hosts a quarterly webinar on how data is being used to transform commercial refrigeration. And this is our Q2 2024 installation of the webinar. So highlighting a few items as we get started. As attendees on the webinar, your camera will be turned off and everyone will be muted. If you have questions during the presentation, we ask that you use the Q&A tab at the bottom of your Zoom screen. You can enter questions there, and there's going to be a Q&A session at the end of today's agenda, and we're going to try to reserve as much time as we can for that. We're also going to make the recording of today's presentation available when it's ready in the coming days. And if you see or hear anything from our panelists that you'd like to learn more about, feel free to send us an email and we can set up a one-on-one anytime. So one key piece about today is that this is not a sales pitch for Axiom, for CoolSys, or SEER 2. Instead, this is an opportunity to have an industry conversation about a highly relevant and urgent topic, which is how doing more of the same isn't an option when it comes to refrigeration. Instead of being a sales pitch, this webinar is meant to start this conversation, and it's a unique opportunity to hear from a panel of experts in the field who are former technicians as well. And these folks really, truly understand the challenges this industry faces up close and personally. Our panelists also have experience how AI is transforming the industry and how becoming predictive is no longer a pipe dream, hence the title. So ideally, retailers and suppliers will learn from our panelists about how to become predictive with refrigeration. Our goal is to help participants evaluate ways to work smarter and not harder. If you were to take just one thing away from today's discussion, it should be that doing more of the same is not a viable option, and the industry needs to approach refrigeration differently if it wants to protect its core business model of selling groceries. Solutions for this critical issue are already being deployed at scale today. So with that, let's do a quick round of intros. I'll start. My name's Amrit. I'm the CEO and co-founder of Axiom Cloud. I've been helping grocery chains and large commercial refrigerated facilities optimize their refrigeration for over 10 years now. Refrigeration is a massive climate opportunity and financial opportunity, which is why I'm here. It's a large, overlooked, and underserved category. We started Axiom a few years ago to solve the biggest problems plaguing this space using software and automation. Today, Axiom serves 15 enterprise customers across hundreds of grocery stores and cold storage facilities, and we're expanding rapidly. And I'm really excited to partner with more of the big grocery and cold storage companies to transform how refrigeration is operated, powered, and maintained. So with that, I'll hand it over to Robert for a quick self-intro.
Thanks, Amrit. So I'm Robert Eidson. I've been in the commercial refrigeration HVAC industry for 30-something years, giving my age away. Worked about every job there is, from engineering to manufacturing to being a field service tech, and proud to say that last week I was on a roof, pulling motors on a roof myself, so haven't lost a touch. Worked about every kind of job there is, traveled the country, been on the retailer side, the vendor side, the installation side, and I appreciate everybody's time who wound up joining this to hear us talk today.
Thanks, Robert. So I just received a text message from Pete Cuneo that he has an emergency. He's unable to join us, unfortunately. During our practice session yesterday, he had so many great contributions. So we'll try to filter some of those into the conversation and misquote him as appropriate here. So Dustin, go ahead and do your self-intro, please.
Yeah, thanks, Amrit. I'm Dustin Tillery with Axiom Cloud. I am one of our refrigeration experts that kind of handles the data in that side of the business. My background, I've been in the refrigeration HVAC trade for, kind of like Robert, I'm going to give away my age, but going on 25, 27 years. Started off myself in the trade, back in the residential side of it, running ductwork, and just have progressed all the way up since, to this point of my career. And, I'm excited for what the future holds for us as a former technician. Seeing the ways that we are simplifying some of the troubleshooting process really gets me excited, because that kind of helps save some time for the technician to devote to other issues. So that part of it I really enjoy. I also like the part of the environmental impact that we are making with Axiom as well. And so that's kind of one of those things that just keeps me going every day.
Love it. Also, great hat, Dustin.
Thank you.
All right. So what are we going to talk about today? So we're going to start by talking about the importance of refrigeration. Why are we talking about it? It is the elephant in the room. The vicious cycle of reactive maintenance, how to break out of that vicious cycle. And then getting into our topic of the day, becoming predictive is no longer a pipe dream thanks to AI. We'll talk about the energy, the maintenance, refrigerant leaks, and then the other benefits, essentially, of becoming predictive. And then we'll meet the panelists a little bit and go into Q&A. So pretty simple agenda here. Let's keep on going. So the elephant in the room is refrigeration. In retail, grocery, and cold storage, refrigeration is almost the entire ballgame when it comes to energy, maintenance, sustainability, operations, and compliance. On the energy side, refrigeration is consuming 60 to 70% of all the energy in the store. So very, very meaningful. And costs are rising even faster than inflation. On the maintenance side, it's estimated that up to 90% of store service calls are driven by refrigeration. So if you don't have a handle on refrigeration, then you definitely don't have a handle on your maintenance. And beyond the cost of paying technicians, there's so many downstream implications of having maintenance emergencies that get back to merchandising and selling groceries and keeping customers and employees happy as well. And of course, there's this vicious cycle we're going to talk about, which is spending all day reacting to emergencies and never being able to catch up. And on the leak side, obviously, refrigerant leaks are of growing importance in our space, not only because of the cost implications of a leak, but also the operational of a business interruption when there's a big leak that causes the store to have temperature issues. And then there's also the compliance element, which is more and more becoming a forefront issue for our industry, from a CSR standpoint, also from a EPA standpoint and CARB standpoint. So we'll talk more about all those. So let's talk about our vicious cycle of reactive maintenance. The vast majority of companies are finding that their reactive maintenance practices really can't keep up with their facility needs. And the scale of the problems are escalating every day. We're stuck in a vicious cycle, but doing more of the same isn't an option. So on the end user side, we're so busy putting out fires all the time that we're basically ending up in a situation where maintenance costs are rising and squeezing profits. We're having customer satisfaction issues because repeated cooling outages and folks are unable to complete their weekly or biweekly shop, and they can't get that ice cream that they want or whatever it might be, or the milk. Poor sustainability metrics. So, for example, dealing with leaks. Right today, the state of dealing with leaks is very poor, and that has a huge implication for sustainability metrics. And then, of course, you have these cooling outage risks, which are bad for everyone, from the CEO and the CFO of that grocery corporation all the way down to the technician, the store manager, the store employee, who are all dealing with the fallout from that. The bottom line is that life is kind of miserable on the end user side today, and a lot of that is because we're stuck in this vicious cycle related to reactive maintenance. Similarly, on the service provider side, life is not all roses and smiles over there either. Basically, there's a shortage of qualified technicians, which is getting worse, not better, every year. And that's a key driver, underlying driver of what's happening in the entire space. And that's getting exacerbated by work-life balance issues, which are leading to turnover. So, overnight service calls, overtime service calls, not enough data available to arm the technicians and enable them to succeed. It just ends up in a situation where the quality of work is becoming lower because we're forcing these technicians to operate in a very specific way, which is not always driving the highest quality. And then ultimately lower profit margins as well, because the cost of providing these maintenance services is going up and up and up as technician wages go up, as the amount of overtime goes up, as repeat service calls increase, unnecessary service calls increase, et cetera. So this is all really contributing to a negative cycle. And the two sides are really fueling one another. So life is miserable on the end user side. Customer relationships are being put at risk on the service provider side. And ultimately, key message is it's getting worse every year. We can't keep doing more of the same. So question for you, Dustin. You were a technician most recently. Can you share your experiences as a field tech? And did you see the quality of your colleagues decreasing or feel pressured to lower the quality of your work in order to speed up?
Yes, to an extent, Amrit. I mean, coming as a former technician, I always wanted to do my best for that customer, which meant doing the job correctly. But there is an increase of that stress, if you will, which has that potential to lower that quality of work. And some of that is due to the specific workload that's being put on the technician. Maybe they have their dispatch calling them every 5 minutes asking for a status update or when they're going to be to the next job. that in a technician's mind does tend to speed them up where things can get overlooked.
Yeah, that's fair. So Robert, as a leader at CoolSys, one of the largest retail grocery management providers in the country, can you comment on the challenges that CoolSys and its peers are facing? Basically along these lines on the right-hand side of the slide.
So, thanks, Amrit. To your point, it's not just CoolSys. So I've worked for the retailer where we had in-house maintenance technicians. I've worked for an international company with in-house technicians, and now I work for CoolSys with in-house technicians. Bottom line is we just don't have enough qualified technicians across the industry. This has been brewing for almost 30 years. In 1988, when I graduated high school, we had welding classes, mechanics classes, carpentry classes, but they were getting rid of that and trying to push everybody to college, away from the trades to college. That was a social experiment that failed miserably, and we're seeing the results of that today. Not everybody needs to go to college. We have people in our trades today that are making as much as vice presidents without a college education. I have hired college degreed engineers as apprentices for the trades today. And they're coming out of school with hundreds of thousands of dollars worth of student loan debt. So bottom line is we don't have enough qualified technicians in the industry. We're not attracting enough technicians in the industry, and this is a problem. So one of the biggest problems is we're robbing from each other all the time. And so it's good for the technician, absolutely great for them if they can get a $5 an hour raise going to my competitor, and then they come back over here for additional $5 raise, 2 years from now. Again, nothing against them taking advantage of that situation, but that's where we're at today. And so costs are going to continue rising because of the demand is going up, but the supply is going down.
Thanks, Robert. So yeah, you perfect lead into this. So today our industry is forcing technicians to move quickly and keep things cold, not really solving problems with an owner's mentality. And so, diving in here on the energy side, it's not because technicians enjoy spending extra energy. It's because we're forcing them to move quickly. We're asking technicians to do, 10 service calls. And rather than really taking their time and thinking about how do I solve the root cause of these issues, we're forcing them to apply Band-Aid solutions, which in many cases lead to energy consumption increasing. So, cranking up a set point might be a quicker way to check the box on a service call and move on to the next 9, rather than trying to figure out what the root cause of the issue is, because there's just not enough time in the day to do that, unless you're going to leave 9 other store managers really upset. On the maintenance side, obviously, technicians are being called after a major emergency occurs. So they're stuck in a immediate hair on fire emergency situation where they just don't have that much of a chance to succeed. Essentially, we're sticking them into a really bad situation and then asking them to perform magic, essentially. And so they have to react really quickly without data. And so that's difficult for early career technicians. So another pressure that is making it less attractive for new folks to join the trade is, we throw them into the boiling water without the right tools or the right data and expect them to try to succeed, and then yell at them when they don't. And then Band-Aid solutions are common as well. So very similarly, folks are trying to make things cold. They're not necessarily working to solve the root cause, and not because they don't want to, because we're not allowing them to. And on the leak side, very similarly, we get upset on the end users get upset because refrigerant leak rates are going through the roof, and they're looking to their service providers. But ultimately, it's really difficult to catch those leaks until the store has virtually run out of gas entirely, using today's tools and today's techniques. And so then even after that leak is caught and the store is in crisis, technicians show up and they add gas, and they have to go to the next 9 service calls again, because again, we're not giving them enough time to solve the root cause. So again, just talking about why this shortage of qualified technicians is fueling the vicious cycle that we're in. And ultimately, the theme that ties us all together is that the industry is forcing technicians to keep things cold and not solve problems with an owner's mentality. let's see, Dustin, you've detected gas and go situations many times while at Axiom, despite all the regulatory requirements and negative impacts on cost and sustainability. As a former tech, can you help us understand kind of what's going through a technician's head when they make this decision? What are some of the reasons they might do that?
So some of the reasons for a gas and go type of situation may be, you know, like you alluded to, just not enough training. Perhaps they don't quite understand, or they're green in the field, and they're not used to using their leak search, their leak detector equipment. Or maybe back to, like we said earlier, about being rushed. Maybe that we come in and we gas it up, or the technician gasses it up, and then they go because they're off to the next call. Again, that making it cold mentality instead of finding the root cause of the situation. Some of those issues as well may be multiple leaks in a site, where the technician goes in and they fix one, and they celebrate, hey, I found it, I fixed it. Let's move on to the next one, and don't do a thorough leak search of the facility. Would be another situation that could happen there as well.
Makes sense. Robert, kind of zooming out, it seems like maintenance leaders are always in a hair on fire emergency. And so many maintenance leaders have to reschedule calls with me, for example, or with members of our team. And it's not a small percentage of the time, it's a really high percentage of the time, because they're dealing with some sort of emergency that came up at the last second. So why are grocery chain maintenance leaders in this really tough reactive situation in the first place?
I've given that a lot of thought over the years, Amrit, and one of the things that we do in our industry is we say, wow, this guy is a fantastic technician. He rocks. Let's make him a manager. And the next day, they somebody, you're a manager. Absolutely no training whatsoever. No training. So now you have a technician who's in a reactive mindset. He's not been trained, he or she's not been trained on the business acumen, the financial part of it, how to plan the work. So that person over time then winds up being the director and the vice president, but they've never been trained on how to get out of that reactive mindset, or how to have a conversation with finance, purchasing, and accounting on how to increase the budgets, how to plan out deferred maintenance costs. So it's almost like they were punished because of their success as a technician to get promoted without the proper training. So they're in this position of authority where they still have the reactive brain, not the proactive brain. It's not trying to plan the work the plan. They're still in that technician mindset, and they haven't been trained how to get out of that technician mindset, or to collaborate with loss prevention, real estate, merchandising, all the other departments within the environment. They don't know how to communicate with them, or how each one of them links back to what they're doing, and how, if they network together, they can actually reduce the amount of reactive calls by getting ahead of the curve.
Interesting. So yeah, it has to do with mindset, with kind of experience and contacts, and with training, it sounds like. So again, leads us perfectly into the next element of the discussion. How do we break out of this vicious cycle? And so the way that we think about it is that there's two elements. The first is prioritizing these proactive actions. So refrigeration is an asset that needs to be proactively maintained. It's not a system we can just ignore and only fix when it's broken. So that means investing in preventative maintenance. Don't defer this stuff. It just builds up and gets worse over time. This is a really big one. Taking action when there are early indicators of problems. Don't ignore until there's an emergency. So, we see this a lot, honestly, in conversations with grocery retailers and cold storage facilities. Is there are early indicators of a problem that are overlooked or ignored or not trusted because they haven't turned into an emergency quite yet, and therefore they haven't risen to the top of the priority list. And so, obviously, you're taking a big risk there, taking a big gamble, and a lot of times you end up in a situation where you have a completely preventable emergency on your hands. Stop spending 100% of your time putting out fires and zoom out. How can these fires be avoided in the first place? So I think this goes back to the mindset shift that Robert was just alluding to. And then, a direct quote from Robert, I like this one, probably 80% of overnight issues occurred hours or days in advance. So when a technician is called out at 2 a.m., they probably could have been called out at 2 p.m. the day before, or maybe even 9 a.m. 2 days before. The second element of the solution, as we see it, is focusing on ROI, not just price. And so this, again, goes back to kind of this ownership mentality where a lot of times stakeholders that we've interacted with are really focused on reducing budget costs that show up in the budget really clearly as budget line items. But ultimately, in many situations, that ends up leading to higher costs overall because there's all these kind of hidden costs associated with decisions that are made. So choosing service contractors based on value, not low cost. So for example, if you're looking at two different service providers and one of them has a slightly lower hourly rate, but the other one with a higher rate ultimately has some way of reducing the amount of repeat service calls, for example, that second service provider might be a better bet. And then assigning value to some of these more hidden costs. So how much value do I want to assign to an unplanned outage, to lost sales, to avoided service calls, to shortened service calls? In many cases, these are really tough to put a number on and then get your CFO to buy into. But at the end of the day, this mindset shift and thinking about the true cost of these decisions, which do involve these categories, that's where real enhancements can be made in operational practices from my standpoint. And then ultimately, arming your team and service providers with data and high value, actionable predictive insights is critical. Without this data, without these insights, it's kind of impossible to be proactive. And it's really tough also to make those ROI calculations. If you don't have the data, you don't have the insights to help drive those. So bottom line, shifting to an owner's mindset is the only way to really break out of this cycle. And using data is the key to enable this mindset shift. Let's see here.
Amrit, do you mind if I say something?
Please.
So the assigned dollar value to unplanned outages, lost sales, avoided service calls, and shortened service calls, I cannot stress how important that is enough. If you work for a retailer, or if you work for where I work at now, we have to show a business case. And if when I used to work for a retailer, I went and worked with our finance department to come up with a cost per measure. And Cuneo was saying the other day that he's done the same thing with his clients. If finance is not involved in those initial discussions, they won't believe the numbers you present to them. So let's just say a compressor goes down and you sit down with finance and you say, this is why I think that each one of these compressors failures is worth $10,000 or whatever the number you come up with. Finance says, I don't believe it's $10,000. I believe it's $5,000. Okay, that's still a number. Let's work with that number. But if you don't have those discussions with finance until after the fact, they'll derate it to zero. There'll be no truth in that number for them. So when we did this, another vendor worked with the customer's finance department on cost avoidance, and we were showing with one guy doing the work 1 day a week. We were showing about a $2 million a month savings in cost avoidance by being more proactive versus reactive. So it's very important, whoever's on this call, that they do this, but they get finances buy-in first. That's it.
Love it. Thanks, Robert. I was just taking a quick note based on your comment. That's very useful. Thank you. Let's see here. So question, Robert, you've seen the impacts that high quality data and analytics can have on energy and maintenance, but a lot of retailers and service providers haven't put their data to work yet. Why do you think that is? Is this because of lack of budget or time or something deeper?
It's multi-point. Part of it is we tend, as human beings, we tend to get complacent and we don't like change. So part of it is backing up, or I like the way you put it here, zoom out, and take a look and really ponder what is driving these reactive calls, and how can we get ahead of them? How can we start attacking them? So one of the things that we're not good at as human beings is embracing change. Plus, unfortunately, we have a lot of snake oil salespeople out in our industry. People with the best thing since sliced bread, and then it's just snake oil and it doesn't work. So we've kind of been burned a couple of times on that too. So part of it is being skeptical of change. So and then part of it, like you said, is also the budgeting, and that's a tough conversation sometimes, and it's scary for some people to have financial discussions with the finance department. And this goes back to what I talked about a minute ago, is they are now in a position where they should be having discussions, budgetary discussions with finance, but they can't because they haven't been trained. But I will tell you that most finance people will give you grace if you just go in there and say, hey, I know I need to do this. I don't know how to get it done. Most of them will help mentor you through the process.
Help to build
So
that.
it is multifaceted problem that we're facing.
And then one thing that Pete mentioned that I want to try to quote here is we were talking about data. And one of the things that Pete said was that most of the time today, the only time that people ever look at their data is after an emergency. And so the question is, how do you change that paradigm so that data is being reviewed before an emergency? And at scale, when you're talking about 500 or 1,000 stores with 500 to 2,000 live data streams each, that's tough if you're using humans to do that. But that's where computers can help. That's where AI can help, is keeping an eye on that data and monitoring it and looking for trends in that data and looking for insights. So topic of the day, becoming predictive is no longer a pipe dream thanks to AI. So implementing an AI-powered refrigeration management solution isn't as difficult or expensive as it may seem. Just quickly setting the table here before we get into examples. This is something that could be implemented in hundreds of stores really quickly. So there's no new hardware, there's no new sensors. It can be installed remotely. Very fast ROI. So this is not the same as changing out a condenser or doing a gas change out where you measure payback in years. This is measuring payback in months. It integrates really easily with existing workflows. So implementing AI doesn't mean you need to change your contractor, your work order management system, your repair and maintenance processes or approval processes. All these things can stay the same, and it can kind of be folded into those existing processes. And ultimately, this is already being done by a lot of end users. A lot of grocery chains, a lot of cold storage companies are already doing this. So this is not new. It's not necessarily unproven at this point. It's already being used. It's already delivering a lot of value. So next up, we're going to talk about how becoming predictive using AI can transform energy maintenance and refrigerant leak management practices. On the energy side, basically using AI can help to identify, prioritize, and solve the largest energy problems and opportunities. So standardizing set points and lockouts are a powerful and really necessary first step. If you haven't done that yet, by all means, please do. But going beyond that usually requires a more site-specific, customized approach. And that's where AI can come in, is helping to drive a lot more value than applying those enterprise-wide standards by making site-specific adjustments. AI is also really great when it comes to identifying and implementing energy enhancements that can be implemented remotely. So there's a lot of energy things that can be done sitting at your computer across your portfolio facilities. You don't always need to roll a truck for those types of issues. Locating and flagging and addressing Band-Aid fixes by technicians quickly to avoid months or years of higher energy use. So this is one that we chatted about with Pete yesterday. But ultimately, he was mentioning that unless you're looking at the data really carefully and proactively, unless you're carefully reviewing those electricity bills each month, if a technician comes in and cranks up a set point, or adds an offset to a sensor that might change how often compressors are running or something like that, that kind of thing can go unnoticed for months, if not years in many cases, until the next major store recommissioning, which is leading to tens or hundreds of thousands of dollars of additional energy use. And ultimately, along those same lines, ensuring sustainability of savings via ongoing analysis of energy usage, so avoiding backsliding. So at the end of the day, you make a bunch of changes, you really tune up the store, get it operating perfectly, make sure that it stays that way for a long time rather than just a few weeks. So key theme here, being predictive with AI enables you to work smarter and not harder. So Dustin, take us through a couple of examples here, if you don't mind, and maybe like 1 minute each.
Yeah, sure, no problem, Amrit. So on this example, what our models identified was a suction float that was not operating correctly during defrost. Quite simply, it was driving that suction pressure down to help maintain the settings there of the case, basically going back to its lowest set point. And that's kind of what we flagged here. But upon further investigation, we revealed that issue, but there was also that further issue down here that you can see with the temperatures of those particular float circuits, that they were not balanced. So the float was not necessarily operating as optimally as it could be due to two factors in this case. Some defrost that was happening here that we can see in the graph where our suction pressure dips down to, roughly 10 PSI, but also without the case temps being, properly balanced, it's not really allowing the system to float up as high as it could, in which case turns into more energy usage.
So it took
On
the
this
whole system
particular
from maybe
example
an
here.
average of 15 or 16 PSI up to maybe 18 or 19, and that's a
Right,
meaning.
right. Yeah, it is a meaningful change, and especially whenever you consider that in this case we're doing it, twice a day for an hour. We go in and we make those changes, and then we can balance it out further so we're not using quite as much energy throughout those times a day. And that really adds up, right? As my dad used to tell me, if you take care of the pennies, the dollars take care of themselves. And so this is a perfect example of that, where over time, as you're taking care of those pennies, you're getting that return in your investment back on the dollars taking care of themselves.
Love it. And here's another example.
Yeah. So this one right here, a perfect example of an energy anomaly. Um, in this case, I believe that we probably have some fan motors or something like that going out. Maybe the condenser coil is dirty. It could be a combination of both of those things, right? And so that is, the higher we push our discharge pressures, the wider our compression ratios get with our compressor, and of course, the more energy we use. So if we're able to keep our condensing temperatures closer to our ambient, then we're going to squeeze more efficiency out of that condenser. In this particular instance, we felt that there's some fan motor issues going on this site. And some of that is because of the dark blue graph that you see there is our discharge pressure. And what we can see there is that our discharge pressure is getting above our fast recovery set point. And when it does that, we're using more energy, right? We're bringing all of those condenser fan motors on at 100% speed in order to try to pull that condensing temperature back down to set point.
So huge energy impacts here, but also there's some real operational impacts as well of getting ahead of this underperforming condenser before the big heat wave of this, the first heat wave of the summer, and suddenly you have big temperature emergencies throughout the entire facility, right?
Yeah,
Absolutely.
Amrit, you
Go
just
ahead, Rob.
touched on something right there. Our technicians, they don't have much of a work-life balance anymore. They got a lot of overtime, and that's good for them. They're raking in some serious dough, but they really don't have a life, and especially during the summer months. So when we get our first heat wave, the number of discharge pressure calls, condenser fans, HVAC calls go through the roof, and they pretty much don't stop until we get a break in the weather. So we talk about the how we don't have enough qualified technicians, and then we basically just we're killing them during the summer. I mean, literally, some of them are working. They shouldn't be, but they are working longer hours than they should, 30 hours straight, to try to stay ahead of things. So any of this stuff that we can find and flag during April, before we have major heat waves and address it in April is one less thing that we've got to send the guys out during the summer to try to fix.
Well, they'll
So
probably
this,
be so tired that it'll take them 2 or 3 service calls to actually solve it anyway, right?
it's not just that. You got to get the parts, because if it is condenser fan motors out, well, I guarantee you that a lot of other retailers have had condenser fan replacements at that time. So now they got to go get the parts, then they got to come back. Then they got to cut the, try to get the blades off the motors, or get new blades. So it's not as simple as just going in there and, and replacing a motor and a 5-minute deal to begin with. And so, yeah, and for every minute or every hour they're working on this problem, they've got 10 more backing up behind them that's making them stressed out. And so again, we don't put our technicians in good spots, especially during summer months.
So perfect segue into maintenance here. So again, it's all about becoming predictive and identifying problems before they become emergencies, just like Robert was saying. Once you've identified these, then the next question becomes, what do you do with all that information? So that's where the batching and triaging comes into play to reduce the number and duration of those service calls. You can also eliminate a bunch of those calls by empowering store employees to solve simple common problems, like closing a door, for example. And then also empowering technicians to solve the root cause during the first site visit. And so that's by providing them with this rich data set of, hey, this is not, for if it's a leak, for example, this is not just a Schrader valve. Like, look how fast it's leaking. So don't go tighten up a Schrader valve and tell me it's done. Let's go find the real root cause. And then flagging Band-Aid fixes to avoid paying for unnecessary callbacks. So that's on if it's a MAC agreement, the contractor is going to pay for that call. If it's a T&M, then the end user is going to pay for that call. But ultimately, it's not good for anyone if you have unnecessary callbacks. And Band-Aids are a key driver of those unnecessary callbacks. So again, key theme here is working smarter, not harder, using data and insights, and AI can help with that. And this is a photo that a member of our team took of a grocery store that was the entire rack was out ostensibly here. So let's look at a couple of quick examples here, Dustin.
Yeah, sure. So what we got here is the condenser itself is underperforming, right? We're kind of in that season, like Robert mentioned there, where we're starting to see the effects of in this case, dirty condenser coil on the system itself, with the inability to meet that set point. The curve itself here kind of resembles just that, a lack of airflow across the coil. And with the particular way that the graph is lined out, that really points to a lack of maintenance more so than a motor itself being out, or a mechanical failure in this instance here. And so this one, probably a dirty coil. Yeah, that would be my first speculation there, quite simply because we're keeping kind of that same difference between our condenser value, our temperature of the liquid versus our set point.
So the key message to the retailer here is
a prime example of.
Oh, sorry, Dustin. I think there's a little delay.
But no, yeah, that's all right. We were going right on the same track there, Elmer. So the key takeaway from this one is the maintenance aspect of it, right? Being able to spot that trend of the set points in temperatures drifting further and further apart, so we can catch it early before major issues happen at 2 a.m. when the condenser's completely stopped up, and Robert's having to send a technician out there with a water hose to wash something off it in the wee hours of the morning that could have been done at noon the day before.
Yeah, Pete said he couldn't count the number of times that he's been out, hosing down a condenser at 2 a.m. That's just that's a sorry state to be in.
It happens more often than what we think.
Here's another maintenance example.
Yeah. So this example, our models and stuff kind of picked up on some cases that started to ice up. In this case, we were able to catch it early, so that the store did not experience as much downtime as they would had it been caught when the system alarmed. So in that sense, we can spot that there's a problem with the case. We can see the temperature, the red line there, trending upwards away from the set point. The fact that it happens relatively slowly would lead me back to believe that the coil itself is icing up, right? Either we have a lack of airflow due to fan motors out, maybe the store didn't go through and wash the cases like they're supposed to, or whatever their scope of work would look like for that. And so that ice would start to slowly build up on that coil. And that's kind of what we see there with this one, with that gradual increase of the temperature. And so by catching this stuff early like this, there's not near as much ice that has to be cleared off the coil. And so we're saving some time there, right? But as well as we're not letting that product, warm up and cool down quite as much. And so we're keeping it fresher as well with this type of preventative maintenance type of scenario here.
Yep. And all, I mean, one of the key features here that I'm noticing is that the other display case on the same exact circuit is fine. So it means it's probably a case specific problem rather than like a liquid problem, for example.
Yes, exactly. And this would be a good way for a newer technician to kind of start narrowing down that troubleshooting process of where do I start, right? I mean, yeah, it's possible that there could be a strainer on that expansion valve that stopped up and slowly stopping up, but that's not really kind of what the data points to. But that still gives them a sense of where to start in order to get to the root cause of the issue.
Yeah, which is the airflow. Perfect.
Amrit, something else about this that we from our side, we normally don't take into consideration is every minute of every day, the store manager has every minute allocated for items for his or her employees to be doing, whether it's sweeping the floor or gathering buggies out of the parking lot. When they have to unstock a case and secure that product in the walk-in cooler and freezer and then restock it later, he or she is now over budget for their labor expenses. So if we catch this early, not only do we reduce the technician's time on site, but also we help keep that store manager or store director help keep them within their budget for their own labor hours.
Yeah, just fewer things to deal with for them. And I mean, then there's also the impact on the shoppers who are confused. They can't find the product, or they end up, having a smaller cart size because they just give up and they leave the store without it.
Yeah, but if you're able to find this problem before it becomes a major problem, then a lot of times the technician can just move some product around. I've seen we got a couple of technicians on the call today. One of them I know for sure, me and him have moved product over to the side to get in there to make repairs, and then we just move the product back when we're done, so we don't have to unstack the case or have the store management unstack the case where there's not what they call holes on the shelves or empty, where it's empty shelves where customers can't buy product. So we can get in and get out a lot faster if we can catch it when the problem's small, not when the system is completely down.
Yep. All right, and finally, leaks. So becoming predictive with AI for leaks. The whole name of the game here is that when a leak begins, there's immediately effects, but those effects kind of multiply over time, and they start affecting all different elements of the business. And over here at 0.7 is when you start seeing temperature issues in the display cases and the walk-ins, and you start having these consequential losses. So put another way, you get temperature problems, and now it's a big hair and fire emergency. And so usually, most retail grocers, most cold storage folks are catching leaks over here at 0.7. And this is when the store the facility has already run out of a lot of gas, if not almost entirely. So the whole name of the game is let's catch leaks much earlier over here at 0.2 or 3. And that's where AI can help. It can be, it can help without any new sensors or receiver retrofits. So you don't need to recertify your pressure vessels. You don't need to add analog receiver level sensors or new sniffers either, whether they're multi-channel or point. And then with AI, you can specify that leak rate to help prioritize. You can identify the location to send your technician in the right direction when they walk in the store. Quickly flag these gas and go type events, which cause the sawtooth graphs to avoid paying for those unnecessary callbacks and extra gas. And ultimately avoid spending valuable time and money on ineffective quarterly or monthly leak checks or monthly manual leak checks. So these manual leak checks, they do check a box for compliance. They do make you compliant for certain programs, like CARB, for example, but they're really not a great solution for catching leaks, because you're only looking at the store once every 90 days, and then you're at the mercy of that technician. Are they paying attention? Are they having a good day? Are they distracted? Are they too tired because they've been overworked, et cetera? They might miss big leaks. So a couple of examples here. And again, same message, work smarter, not harder. So a couple examples, Dustin.
Yeah. So on this example, Amrit, we identified a leak. In this case, it was our leak detector that is hanging in the motor room itself, in the rack house. Uh, and through our technology and our data ingestion, we were able to identify where we suspect that leak may be based off of the graphs. The red line being the ppm, parts per million, from the leak detector itself, and then with some discovery process throughout, throughout our anomaly, construction, I say, we're able to go in and really, in this case, pinpoint where we believe the leak is based off the data that we're given. This really helps to speed up the technician's time. Gives them an idea of where to prioritize their leak searching at. In this case, again, like I said, the rack leak detector being in the rack house, um, nothing really looked obvious there until we started going through the EPR valves. And then we see that the EPR valve for the service fish case is cycling, up and down, just like we would expect the valve to, but so is our ppm level in kind of a correspondence with that valve. And so we were able to take that data and put them together and basically tell the story of where we believe the leak is. And again, it's a time savings for the technician. Not saying that a technician should still go ahead and leak check everything while they're there, right? Just to ensure that what we're presenting to them is correct, but also to ensure that there's not any other leaks in the store. But at least with this data that we're giving them, they're able to go in and again focus their leak search on this one particular area and resolve this leak, and then move over to other spots and fill out the rest of their obligation to the customer.
Yep. So here's another one.
Yep. And on this one right here, what we're looking at is a receiver leak. This one kind of goes back to that gas and go, or even a Band-Aid fix, if you will. We're pulling here the red trace being the receiver level. We can see that it was flat up until sometime mid-November, when it appears that somebody came in, added some gas to it, let it go for, we'll say, about a month, right? And then it appears that maybe it was a catastrophic event. Maybe a vibration isolator broke loose and we lost a hose or something coming off the discharge of a compressor or something like that, right? And so then we see that right there just after December, between December and January, that steep drop of that receiver level. So that gas had to go somewhere. And it's just not hanging out in the pipes, not doing anything. It unfortunately was released to the atmosphere. And we can see that throughout the graph. And then, again, Band-Aid fix, somebody went in, put more gas in the system, and maybe they solved one leak, but in this case, there's still a leak on the system, as is evident by the trend down of our receiver level.
Yep. So just kind of putting this in context here, looking at, so here's a leak digest for one of our customers, with they have over 100 sites. I forget the exact number with Axiom today, but ultimately just giving you guys a sense of like, this is the type of data that AI can provide when it comes to leaks. So, which facility is the leak in? What's the leak rate in pounds per day? How much has been lost since the last refill? And how much could you save over the next 90 days if we're ultimately resolving this in a timely fashion? And so this helps our customers to ultimately figure out, what's the most effective set of actions that I can take right now to drive down my global leak rate? And that's by focusing on these biggest leaks first. So continuing to kind of rocket forward here, just so we can spend some time on Q&A. Becoming predictive with AI has lots of other benefits too. There's obviously compliance, and the next webinar we do will be focused on that. And we're also, I think we forgot to show examples this time of sensorless leak detection, but we'll do that next time, of showing leaks that are detected not just by PPM sensors or not just by receiver level sensors, but also in facilities that don't have any of those sensors. And we catch a lot of those leaks as well. Sustainability, so driving down the single largest driver of scope 1 and 2 emissions, which is refrigerant leaks, and then employee and contractor retention. So this is coming back to the work-life balance element and arming these folks with the right tools to succeed. And then customer satisfaction. So don't let these unplanned outages impact customer loyalty or cart size. So again, same key theme, working smarter, not harder. Of course, we could talk a lot about Axiom specifically, but visit our website if you have any questions about that. Ultimately, we are able to help a lot of folks at a lot of different grocers. We're in about 15 big grocery chains and cold storage companies today across hundreds and hundreds of facilities. Yeah, would love to chat more about it if there's interest at any point. But let's spend the rest of our time on Q&A. So I'm going to open up our Q&A to see what kind of questions we have available. All right, first question. My stores don't all have reliable sensors and each store is different. None of my stores have receiver level sensors. Okay, that is pretty common. We see that a lot. One of the really important things to know about this industry, for anyone who doesn't already know this, I guess, is that every single store, no matter what the manufacturers tell you, no matter what the facilities folks tell you, every single store is a snowflake at the end of the day. And I know that may be a little bit controversial to say, but every single store is slightly different in terms of what equipment is there, how old it is, what types of sensors are there, which engineering firm spec'd it, which technicians installed it, which folks programmed it. It's all different across the board, with the names of the points, the types of data, the offsets, the everything. And so at the end of the day, being really flexible and having the ability to understand those differences and make sense of them is fundamental. If you don't have that ability, then you're bound to fail in this space. And so, whichever AI partner you guys decide to work with, make sure that that's a really key competency that company has. And so, yeah, long story short, the ability to be flexible and address stores with different sensor configurations and different data types and different frequencies of data being stored, et cetera. All that stuff is okay. And ultimately, the beauty of these models is that they are very flexible and they're able to use, the AI is able to kind of fill in the gaps almost. Another really cool part is what we call data validation. So in situations where data isn't available, or it's very clear the data is untrustworthy, or there's been a big change in the facility, that's where data validation engine comes into play. And that's constantly re-evaluating and re-validating that data on an ongoing basis to make sure that the data can be used to make business decisions and flag insights and things like that. And ultimately, for example, if a technician comes in and puts an offset on a sensor, or if an end cap gets changed from beer to Peeps for Easter, whatever it might be, suddenly there's going to be a lot of changes in that refrigeration system configuration, and those types of things can be flagged. And that new logic is then applied when flagging insights or flagging problems, for example. So long story short, if you don't have reliable sensors, if your stores are all different, if you don't have receiver level sensors, that's generally okay. As long as you have a controller that's connected to the internet, and almost every store out there does. Of course, there's some exceptions, but the vast, vast majority of stores already do. Then you have what you need to start with AI. All right, other questions. A lot of companies have tried and failed to use analytics for refrigeration before. Some of these were Emerson, IMS, and others. What prevented these efforts from taking off and transforming the industry and is now different? Any thoughts on this, Robert?
Yeah, so I don't consider IMS or Emerson, which is Copeland now, a failure, a quote unquote failure, because I'm familiar with both systems. Just I think a lot of it really comes down to the implementation of the system when it's deployed, aligning expectations, which is one thing. So a guy told me one time, he says, when you have a vision and your partner has a vision, but they're two different visions, that's called division. So you have to align your vision. So a lot of times what I see happening, whether it's this or other new technology that comes up in the industry, is a lot of times the visions are not aligned to start with. Second thing I see happen, especially with this, is we're not involving the right departments a lot of times. We only deal with facilities management. Actually, we need to be talking to finance, the chief information or chief technology officer, IT. There's so many other departments we should be talking to, because I guarantee you most retailers, their CTO or CIO has got AI for customer experience shopping, where they're pulling in social media data along with point of sales data. And they could be pulling in this data to also then correlate why they're not selling meat last month at a particular location. So I think we miss the boat a lot of times when we go to implement new stuff, because we're so excited to get it out there, but we don't step back and we don't plan the work the plan. We don't think it all the way through and then say, okay, how many touch points are there? And I need to go ahead and reach out to those department or those people and bring them into the conversation, because sooner or later this will touch them. So I don't consider Emerson or IMS a failure, as much as it's probably a human failure, just in the planning and coordination and collaboration.
That makes sense. All right, last question of the day. How can you reliably predict refrigerant leaks without knowing liquid receiver levels? That's a really great question. And so this comes down to essentially using the AI to look at system level traces, system level indicators in conjunction with one another. So put another way, we're looking at 8 different families of indicators today. So those are things like superheat values. We're looking at valve positions. We're looking at, I couldn't even tell you what all 8 are, but it's these 8 different families. And the cool thing about AI is that, for example, if this month the superheat is 2 degrees higher than it was last month under a certain set of operating conditions, that's not really meaningful or interesting information in isolation. And most humans, if they were to really pour into really looking over the data super carefully, they may or may not even notice that. It's just not that meaningful. And so the AI is able to look at that, and then it's also able to say, okay, interesting, this compressor over here is running 10% more than it was, and this valve is closed 10% more than it was last month under similar operating conditions. And so then the AI is able to start connecting those dots and understand, look, across this family of 8 indicators, we're noticing really small performance deviations that are indicative of a potential leak. And so at that point, when it reaches a certain level of confidence, and I think our threshold right now is 98.5%, that there's a leak, at that point, we are triggering an alert. And a very important part of the process here is that humans are involved. So when we're seeing these types of alerts that are triggered by the AI, at that point we get experts, US-based experts like Dustin, involved to look at every single one of those and validate them before they go out to customers, because false positives, or nobody likes false positives. And so that's how we're able to identify leaks, even in facilities that don't have those receiver level sensors, and even in facilities that don't have those PPM sniffers. So we are past the hour here. We're going to have to pause there. But thank you so much for participating in today's discussion. And we will definitely let you know when the next one is. Thanks all, and have a great Tuesday.